Good afternoon, everyone. We are now live in Onshape users worldwide for Introduction to Computer-Aided Design with Onshape. So, inviting everyone to join us in YouTube, Facebook, and in LinkedIn. Onshape users worldwide, and inviting you to like and follow our page to get updates on our upcoming trainings. Also inviting you to join Digital Creatives Philippines. So don't forget to click the registration form for you to receive a certificate of course completion or event participation. Okay, hi everyone. So today we'll be having introduction to CAD with Onshape. So let me give you some insights what Onshape is. Okay. So why should you use Onshape? So Onshape is easy setup, collaboration, and versioning, overall stability and ease of use, and you can also do multi-part modeling, automation with future script. Onshape has a sheet metal tools and in context designs. Okay, then the setup, Onshape is available on any device anywhere, no? You can use Onshape anytime, anywhere, no? So Onshape is the only CAD system that allows you to do all of your CAD work on your mobile device, no? So Onshape's iOS and Android apps are optimized for phones and tablets, allowing you the flexibility to access, collaborate, and edit your CAD data anytime, anywhere, on any device, no? So Onshape can be used on Windows, Linux, Mac, and mobile. Works as soon as you make an account, no? You don't need to install the software. Okay, broadband is required but performs well enough on slow broadband. Okay, much faster than other CAD softwares on most machines. Okay, no, so let me introduce your instructor for today. Okay, so let me leave you muna with a very short video.
Onshape is the only product design platform built from scratch using the latest cloud, web and mobile technologies to complement the way today's professional design teams really work. With Onshape's unique database architecture, you can build complex parametric parts, assemblies and production-ready drawings together as a team. Unlike old CAD, data management is built in, so there's no waiting for files to be checked in or checked out, no accidental overwrites, and no expensive PDM software. You can explore new concepts, new ideas and new design scenarios simultaneously within the same document, merge changes together, and browse every design change ever made, so your entire team can design with confidence. Sharing design data with your team, your suppliers, and even your customers is easy. Simply enter their email address, assign access rights, and click Share. Clicking the link in the email opens your document in a browser or the Onshape mobile app for instant editing or viewing. Sending CAD files in unsecure email attachments is now a thing of the past. For the first time in the history of CAD, teams can work together on the same assembly, same part, even the same sketch for true real-time collaboration. As team members edit or create new features, updates are reflected everywhere, within seconds, so the entire team can see the impact of a design change instantly. With simultaneous access to the same CAD data, design workloads can be shared easily. Every team member, partner or supplier can contribute in real time with no restrictions, enabling projects to be completed in record time while maintaining full control over your company's intellectual property. Whether your team is located in the same office or across several time zones, Onshape's powerful collaboration tools inspire teamwork and boost your productivity. Teams work better in Onshape.
Yan, so inviting everyone to please share our live stream to your classmates and to your colleagues who might be interested in this session. So let me introduce to you our instructor for today, for this session, no? Engineer Jomark Bakiran.
Okay, mic test. Test mic. So once more, thank you so much to our supporters who made this live stream possible. Our friends in Palawan State University, College of Engineering Arts Technology, College Student Government. Also, thank you to Mapua MME Student Council. In addition, many thanks to our friends in Philippine Society of Mechanical Engineers, Polytechnic University of the Philippines Student Unit. Good afternoon to our friends in PSME, Bicol Regional Council of Student Units, and to our friends in Wacom Users Community. Same with our friends in BIM Philippines and Digital Creatives Philippines. Okay, so once more, welcome everyone to Introduction to CAD with Onshape. Yep, in addition, we are also, to our friends in YouTube, sharing to you that we are also live in Twitch via Digital Creatives Philippines, in YouTube as well via Onshape users worldwide. Yep, and once more before we begin, inviting you to join us as we create the largest Onshape user group in the world with Onshape users worldwide. So this group is, we are also linked in via Onshape users worldwide. So hoping to see you all there. We will be posting updates, latest tutorials for that. Okay. Good afternoon to Peter. Okay. Okay, so this is a short and a sweet introduction for you guys to discover and share to you some of the compelling reasons to use Onshape. Okay. And before we begin, inviting our students and educators to sign up for Onshape. So again, as mentioned by Ms. Nelsie a while ago, you don't need to install Onshape actually. All you need to do is open a web browser to access Onshape. So that's one of the reasons why it is the ease of use and its awesomeness. Okay, so to access, if you have already created an account in Onshape, the quick way to access Onshape is simply typing cad.onshape.com. So notice on my web browser, I'm going to hit enter. And because I have allowed Chrome to remember my password, it logs in right away. So once more, I did not install Onshape on any device. I am currently using Onshape in a web browser. So imagine that there's no need to invest in a costly CAD workstation. Okay, yeah, and to those who has Chromebooks, this will also run in Chromebook, of course, being in a web browser. Okay, so let's begin. So for today, I'll be showing you how to create simple parts in Onshape, and group that parts, add mates, and turn that parts into a dynamic assembly. And before we begin, we have a reference drawing for that. Let me share this to you. To all who has registered in this live stream training, we will be forwarding this 2D drawing to you guys. So if you would like to have a certificate of course completion, highly suggesting you register now. The links in the video description below. So this is a drawing I took up from a book teaching SolidWorks. Okay, so I'll be using that book. Imagine that I'll be using that book in order for me to share Onshape. So that's how versatile Onshape is. Okay, so in the 2D drawing, our challenge is defined in millimeters. Okay? And this challenge, notice, has three parts. Okay, one being the plate, the other one crosslink, and the other one linked. So once more, these are all defined in millimeters. So with that in mind, let's set our length or units in millimeters in Onshape. And to do that, it's simple. It's heading over to my profile. I'm going to go over to my account. Head over to preferences. And if yours is different from mine, simply select this drop down and select millimeter. Okay? And of course, select save changes. So once more, Onshape is like a Google Docs. So if you're familiar with Google Sheets, Google Slides, imagine Onshape as a Google Doc for CAD. So to head back to Onshape's the dashboard, simply head up on the upper left, going back to Documents. So again, same with Google Docs. What we're doing in Onshape is also named as a document. So let's begin. It's simple. I'm going to head up to Create, and of course, we are opting to create a new Onshape document. Okay, so I'm going to name this as, let's say, Intro to -CAD. And select Create Public Document. So as you can see, this is a public document wherein, of course, everyone who has a free account can also view and search for this document. Yep. So once more, I'm just using a free account in Onshape. Okay, so here's the user interface. If you're familiar with other CAD packages, yes, you are surprised that it's the same as well. So today we'll be sharing to you the compelling or the difference in addition about Onshape and other CAD programs out there. So let's start off by creating a new part. Okay, so notice this assembly. What I am seeing here is the two parts are referencing this part over here, which is named as the plate. Okay, so with that in mind, we have identified what our parent component is, or part, which is the plate. So in addition, we can, as a personal preference, I prefer creating the plate right away, or any of the three will do. But for this session, I prefer the plate. Okay, so going back to our graphics area, And the controls are also simple in Onshape. So before we start, let me create a simple 3D model to show you how easy it is to create a simple part in Onshape. So initially, think of it as we are given 3 papers, right? And that 3 papers that we are going to sketch on is the front plane, the right plane, and the top plane. Okay? So typically, it all starts with a 2D sketch, right? So before even CAD systems began, okay, we are creating parts, products, initially hand drawn during the old times, right? So the same application goes up to now. So we will initially start off by creating a sketch. So I'm going to head up to our sketch features toolbar, selecting create sketch. We are now prompted to select a sketch plane. I'm going to select our top plane, so I prefer sketching on that. Okay. So next, notice our toolbar changed. Okay, we have a new set of icons here pertaining to what our current sketch mode is. Okay, so notice once more again, we are going to sketch on the top plane. So let's create a quick 3D model. I'm going to select corner rectangle. I'm going to create a quick rectangle over here. Hit the green check mark. So notice we have now created a sketch region. And we are now out of the sketch mode. Next, I'm going to head over to extrude. We are now prompted to select sketch regions. And this is now our sketch region, selecting this. And from here, as simple as that, in a matter of seconds, we have created a new 3D model. So I'm going to commit to this, hitting the green check mark. For the controls of Onshape, it is also very typical with some of the other CAD packages out there. To rotate, it's simply holding my right mouse button. Okay, once more, right mouse button to rotate. Okay, to zoom out, it's simply scrolling or rolling over your scroll wheel. So I'm going to zoom this far out. And to have it bring back for a zoom extents, it's simply double clicking your middle mouse button. Okay, middle mouse button to zoom extents. And to pan, it's simply holding your wheel mouse to pan. Okay, so that's the controls for using Onshape. And to revert back to our default home view or isometric view is simply hitting Shift 7. Now, an additional tip for the list of shortcut keyboards is simply holding Shift and the question mark with our / for the list of keyboard shortcuts. So once more, Shift and the question mark for the list of keyboard shortcuts. So what I normally select here is the isometric view. The normal to take note of that to be N. So once more, Shift and holding Shift and the question mark to access this keyboard shortcuts. Okay, so simple as that. We have created a 3D model in Onshape. Moving forward, let's now create our target challenge. So I'm going to delete what we have created. I'm going to hover over our feature tree, selecting sketch 1 and extrude 2 and simply hitting delete on my keyboard. Okay, once more, Shift 7 to go back to isometric view. And let's start off by creating our plate. So our plate has a dimension of 40 by 120. So in this instance, I prefer creating our plate or starting our sketch on the front plane. So once more, let's head back and select sketch, prompted to select a sketch plane. I'm going to select our front plane. And to have the view normal to our site, it's simply hitting N to view normal to. So notice on our feature tree, I am seeing a new feature here called Sketch 1. Okay, so as we progress in creating parts, assemblies, and models in Onshape, your feature tree will be populated. Next, let's start creating that rectangle. So I'm going to head up and select center point rectangle. So take note of the shortcut key. It's R. Okay. So next, I'm going to drop its center point at the origin. So once more, the origin, we have the Cartesian planes representing the X, Y, Z. So that origin, that coordinate is 0, 0, 0, 0. Okay. So this is the origin. Okay, so let's define the dimensions of this rectangle. I'm going to left click for now. So notice the dimension on at the bottom, currently at 94.277, is currently highlighted in a black bordered rectangle. So that means that is the current active dimension. Okay, so with that in mind, I can type in 120. I'm going to hit enter. The dimension field on the left is now active, currently at 63. So with that, I'm going to hit 4E. Okay, so notice I'm going to hit undo for now. I want you also to be aware. Okay, so I hit back I move one step back. Okay, relinquishing that 40 dimension. So notice here our sketch entities. Okay, so this line is currently in black color. Okay, and the other one, this horizontal line, is currently in blue. Okay, so the difference between the two is if you're seeing your sketch entity turned into black, that means that entity is currently fully constrained or fully defined. And if it's in a blue color, it is not yet fully defined. Okay, so notice once more as I re-add the dimension defining the distance between this horizontal line and this horizontal line, this will turn into black. So let's head up. I'm going to select dimension. Okay, so notice the crosshair. I'm going to hover over. Also, in addition, whenever it turns into color orange, so that's an indication that if you left click, okay, if you commit to that by left clicking, it will be selected. So I'm going to hover over this horizontal line. So notice it turns into an orange color. I'm going to left click on that. Left click on this horizontal line. So next, let's place our dimension over here. I'm going to left click to place it here. And I'm going to type in 4P. Okay, so once more, notice it turned into black. And as I'm going to hit escape to disable dimension, notice as I left click and hold to force this horizontal line to move, these are now all locked in place. Okay, so once more, hitting N to view normal too. So we have a hole on this rectangle. So let's add that up as well. Let's head up under this drop down. Let's select center point circle. Okay. So I prefer, instead of creating the circles here, I prefer creating the two circles here. So left click here, and left click here. What I would like to share to our dearest students right now is the importance of sketch constraints. In addition, we can toggle or see what our current sketch constraints is by simply heading over to the sketch window and enabling show constraints. So notice here on our rectangle, I am currently seeing a coincident constraint, a parallel constraint, okay, a horizontal constraint. So this is an indication as well on what constraint needs to be added. Okay, so let's have this two circles fully constrained as well. So let me start off by hitting D for dimension. I'm going to define the diameter of this circle. I'm going to key in 10. Okay, and I'm going to hit escape. My intent here is to add intelligence by adding constraints. So notice this circle is also 10. And instead of adding a dimension on this circle, we can utilize our sketch constraints for that. So I'm going to head up and select equal. I'm going to select the circumference of this circle. Hovering over, it turns into orange color. Left click, move to the other one, and left click. Okay, going to hit escape. And notice, because show constraints is turned on, I am seeing an equal constraint. And as I hover over this equal symbol, notice the other circle highlights also into an orange color. So that is currently saying to us or indicating that the equal relationship was added to both of these circles. Okay, so next, let's define the distance between these two circles. So the shortcut key for dimension is simply hitting D on our keyboard, hovering over this center point, left click on this, left click on this, placing our dimension here, left click, and let me define this to be 80. Hitting escape. So another great tip when doing sketches is always to move entities. So I'm going to hover over the center point of this right circle. I'm going to left click and hold. Okay. So what I am seeing here, as I am constantly moving this circle, is the center point of these two circles should be aligned horizontally. Okay, so that's the benefit of troubleshooting by moving your sketch entities. It gives us an insight if our sketch needs a constraint or needs a dimension. So I'm going to head over to our sketch constraints. I'm going to select horizontal, selecting this center point and this center point. Hitting escape. So notice the relationships added between this circle. And as I left click and hold and move the circle on the right, the circle on the left is also moving because of the relationships applied. Okay, so our next step is to move these two circles over here. So to do that, what I am seeing is I'm going to be creating a line. So let's head up. I'm going to select a line. Place our first point here and the next point on the center point of the circle. And I would like the midpoint of this line coincident with our origin. So to do that, it's simply heading over to midpoint. Midpoint constraint active. I'm going to hover over this horizontal line. It turns into an orange color. I'm going to commit to this. Left click and select our origin. Left click here. Hitting escape. So notice it turned into black, which means our sketch is now fully defined. In addition, this horizontal line is just a sort of a helper, okay, in helping us out attach these two lines to its intended position. And to clean things up, it's a best practice if this is not if this is just a helper, it's much better to convert this into a construction entity. So to do that, I'm going to select our horizontal line. And notice also on my cursor, okay, my arrow cursor, there's a number 1 attached to it. So that 1 currently denotes that I have currently one selection. Okay, so notice as I hold shift and select this other horizontal line is now 2. Okay, once more selecting this horizontal line, and let's turn this into a construction entity. I'm going to head up and simply select construction, hitting Q on our keyboard as well. So notice this is now a dashed line. Okay, so congratulations for completing our first sketch for our plate part. So we're done. The next step would be selecting the green check mark. Okay, so notice it registers on our feature 3 as a sketch 1. Okay, so next, let's now turn this sketch into 3D. So it's simple. It's simply heading up and selecting Shift E. Okay, so prompted to select new faces or sketch regions. I'm going to select this sketch region. Left click here. Okay. And another important tip or best practice is, as much as possible, okay, make it a habit to place or orient your origin to the center as much as we can. So notice on our current model, as I head over to our view cube and select this top face of our view cube, our origin is currently here. Okay. So once more, one of the best practice is to have our origin at the center or middle. So to do that, for the direction, I'm going to select this drop down and change change the direction options to symmetric. Okay, so notice now our origin is now at the middle or center of our part. Okay, so for the thickness for this plate, it will be 15. I'm going to type in 15, hitting enter, and let's commit to this action, selecting the green check mark. And notice on our feature 3, it is now registered as extrude 1. Okay, so this is, in addition, Onshape is a parametric CAD software. So with that, what that means is it registers the parameters from the word itself. And with that, it stores the parameters as well. So if ever you have the need, of course, aside from the only constant thing in this world is change, it also applies to design. Let's say our design manager instructed us to change the diameter of this hose. It's simple. It's simply heading up to sketch 1, right click and selecting edit. So let's say our design manager would like this circle to be 15. Notice as I hit enter and hit the green check mark, this hole is now also having a diameter of 15. So I know that because once as I select this circular edge at the lower right, we are given the diameter value to be 15. So in addition, I want you to take note to those who are absolute beginners to take note of how sketch constraints, dimensions, and features relate or stack up to one another. Okay, so I'm going to revert back to that previous dimension, heading back to sketch 1, selecting right click on this, selecting edit, double click on this 15 diameter, keying in 10. Hitting the green check mark. Of course, let's always be organized. So we may be creating a simple part here, but I'm sure as you progress, you'll be creating more complex assemblies. So, and one tip is always getting organized. So with that, I'm going to head over to this lower tab, currently named as a Part Studio. I'm going to right click on this and select rename. So this is currently named as a plate on the 2D drawing. Typing in plate, hitting enter. Okay, so we're done on our first part. So if you're, to those who are familiar with other CAD programs out there, notice I have created a one solid body. In Onshape, it's registered as a part. So notice here I have a part 1. And as Nelsie mentioned a while ago, one of the key powerful features of Onshape is creating multi-body parts in Onshape. So hitting Shift 7, I prefer always seeing my model in isometric view. Moving forward, let's create our third model or part. Okay, inspecting. So here I prefer creating our crosslink. So once more, okay, so instead of heading up to documents, notice we are currently in a document. And to create or insert to create a new part, it's simply heading over to our lower left. Once more on the lower left, let me turn this announcement down. Yep. So at the lower left, okay, it's simply creating this or selecting this plus button, insert new element. So we are given here tons of options in this instance. Our goal is to create a new part studio. Okay, so I'm going to select this. So it kind of reminds me of Google Sheets, right? The tabs on the lower left. So we have our new part studio right now. It's currently empty. We haven't created anything yet. So for organization, let me head up to our tab once more, currently named as Part Studio 1. I'm going to right click on this and select rename. Let's rename this to crosslink. Hitting enter. Okay, so next, let's create the sketch for our crosslink. So last time, we head over to our toolbar and selected sketch. Let me show you another way, which is selecting the front plane on our graphics window. So once more, it is currently highlighted in orange. So with that, I can right click and select new sketch. Okay, so I am used to I am familiar with other CAD programs out there as well. And the typical thing with them is it automatically switches to normal view. So with Onshape, we have to click N to view normal too. So some other designers prefer that. So I prefer having the view always normal to my site. So moving forward, let's create this part. So this part is shaped like a slot, but let me show you the typical method. So I'm going to hit L for now. So once more, the cursor turned into a crosshair. So an indication of what tool you are currently in. I'm going to left click over here. Next, I want to share to you the inferred constraint. So notice, as I slowly move my cursor to the right, there's a horizontal line appearing on the lower right of my cursor, the crosshair. So that is an inferred constraint. So that is suggesting to us that if I left click and hit escape, Onshape automatically gave us or added a horizontal constraint for this horizontal line. So I'm going to select this. If ever there's a need that you want to disable that inferred or suggested constraint, it's simply holding shift. Okay, so possibly you wanted to create a slanted or diagonal line. Okay, so what I did is I simply hold my shift button to disable that suggested constraints. Now, these constraints are contextual, so which means it varies and it depends on what you will be creating. Okay, so once more, I'm going to hit L. Let's create that line right away, committing to this horizontal line. Left click also. So with lines, notice I performed a single click. Okay, so with that, I created a chain of lines. So left click here, left click here. If ever you want to terminate the creation of this chain of lines, it's simply double clicking. Okay, so notice we are not creating a chain of line anymore, but our line tool is still active, which means I can still create a line. Okay, so double left click once more to end the chain of lines. Another tip, I'm going to create a window selection, deleting these lines and this line. Next, I prefer creating an arc. Also, we can create a circle. So I'm going to head up, selecting a 3-point arc. Take note of the shortcut key for that. Arc tool active. Let me place our first point here. Left click on this endpoint. And here's another inferred constraint coming up. So notice Onshape is suggesting a tangent constraint. So notice that slanted line with a circle touching that line. So that's a coincident line. Let me commit to this. Left click. Our arc tool still active. Selecting this endpoint and this endpoint. Once more, notice the inferred tangent constraint. I'm going to commit to this and left click. Hitting escape. Okay. So let me turn on our show constraints to see what constraints needs to be added. So if I hover over this constraint, notice the arc on the left and the bottom horizontal line turned into a orange color. So which means both of them shares the tangent constraint. So with that, and with this knowledge as well, we need to add a tangent constraint between this circle and this horizontal line. So let's head up, selecting tangent. Let me select this arc and this horizontal line, this arc and this horizontal line. Hitting escape. Let's add the circles as well. Shortcut key for that is C. Placing our circle on the center point of this arc. Left click here. Creating another circle here. Left click. Hit escape. So notice I did not input any value for now. I'm just merely creating the general or outline of our sketch. So next, let's now add dimensions. I prefer dimensioning the circle. So I'm going to hit D for circle, selecting this circle. Diameter for this, based on our 2D drawing, is 10. Notice it automatically scaled up with our first dimension. So that's one of the cool thing with Onshape. It scaled our whole sketch, confirming to our initial dimension. Next, let me grab our dimension tool once more. Let's dimension this arc to be 10. Okay. Hitting escape. So let me inspect our sketch. Left click and hold to any of this sketch entities. Once more, I'm reiterating this practice in order for you to determine if your sketch needs to have a constraint or dimension. So notice here, I am currently stretching our slot. So with that in mind, let's define the distance between this center point and this center point. I'm going to hit D for that. For dimensions, selecting this center point and this center point, left click, placing our dimension here, key in a T. Hitting enter. Okay, so once more, let's position this sketch as a best practice. Okay, so the center of the sketch is somewhere around here, right? So let's position our origin on that as well. And to exactly do that, let's create another line. I'm going to create a line, but first I want to show you the effect of constraints, reiterating that. Once more line, creating a line from this center point, going to this center point, left click and hitting escape. Let's turn this into a construction entity. Selecting this horizontal line and hitting Q. Once more, the shortcut for construction. And finally, let's head up to midpoint. Our intent is to have the midpoint of this horizontal line coincident with our origin. Okay, so congratulations. And one more thing, I'm seeing this circle in blue, and by now you guessed it right. We need to add a equal constraint. So the design intent for this is basically these two circles having that equal diameter. That's why it's a best practice, instead of having another diameter here or dimension, we are going to add an equal constraint instead. So once more, selecting equal, selecting this circle and this circle. It turned it to black. Once more, it's now fully defined. Holding my right mouse button to rotate and hitting Shift 7 for isometric view or home view. Let's exit out of the sketch, selecting this green check mark. Sketch 1 registered. And the shortcut key for extrude is Shift E. Prompt is to select sketch region, selecting the sketch region. Once more, best practice, making our origin at the middle or center with respect to our part as much as possible. For the direction, changing this to symmetric. And for the thickness of this model, it will be 10. And hitting enter. Selecting the green check mark. We have now created our second part. In addition, if you prefer hiding the planes once more, it's simply hitting P for turning off the visibility of our planes. So notice as I hover over top, the eyeball is currently slashed, which means it's turned off. So once more, hitting P to turn it on. Okay? And for to those who are latecomers, to access the keyboard shortcuts for Onshape, it's simply holding Shift and the question mark. Okay, so here's the list of the keyboard shortcuts for you to quickly recall and remember. 7 for isometric view, and let's move forward. Let's create the third part. Okay, so this one is named as a link, L and R. So let's name this as link only. Once more, to create a new part in an Onshape document, it's simply heading to the lower left, selecting this plus button, insert new element, creating new part studio, selecting that, loading studio data, part studio, hovering over here, this tab, right click, selecting rename for organization, being organized, typing in link. Okay, so let's now head to sketch view. And once more, I prefer sketching on our front plane. So notice previously, we started out creating a sketch on our toolbar. The previous one, selecting our front plane. This time, I'm going to head over to our feature tree. I'm going to hover over front plane. Right-click on this and create new sketch. I prefer having a view normal too. Hitting N for that. Let's recreate that part. But this has a different dimension. Hitting L for line, left click here, double left click. So notice I accidentally created a new line, creating a window selection, and hitting delete. Hitting L once more, left click, and double left click. Okay, so this time, instead of creating an arc, let's spice things up. I'm going to create a circle instead, creating a circle here and circle here for demonstration purposes. Okay, next, let's add a tangent constraint to reiterate our tangent tool. So once more, selecting tangent constraint, selecting this horizontal line and this circle, and I'm going to hit escape, and I want to show our absolute beginners watching right now the effect of having a tangent constraint. Okay, so as I move this circle, it looks like it is bounded by a invisible line over here. So this is the effect of a tangent, and one of its use is when creating smooth transitions. Okay, so we will be creating that in a moment. Let's grab our tangent constraint once more. I want this circle and this horizontal line tangent with each other. Same with this circle and this horizontal line, and this circle. Hitting escape. Okay, so next, our intent is to have this endpoint touching the circumference of this circle. So to do that, it's simply heading up and selecting coincident. So we want this coincident with each other, specifically this endpoint, selecting this and this circle. Okay, so notice here we have a gap, coincident constraint still active, selecting this endpoint and this circle, this endpoint and this circle, this endpoint and this circle. Okay, so moving forward, I want you to be familiar as well with sketch regions. In this instance, we now have 3 sketch regions, and those sketch regions are depicted or visually indicated by this grayish color. So this one is a sketch region, this one is a sketch region, and this one is a sketch region. Okay, so let's have this sketch be looking like our 2D drawing. So I'm going to utilize, for now, I'm going to show you our trim command. Once more, the shortcut for that is M. So with trim, I'm going to hover over this section of the circle. Left click on this to select. And selecting this segment or piece of the circle as well. Left click. Okay. Going forward. Let's inspect once more, another best practice. I prefer adding the line for now. Hitting L for line, creating a line from here, going up to here. Hitting escape. Let's grab our midpoint. Selecting this horizontal line and our origin. Hitting escape. So yep, once more. Let's turn this into a construction entity. Hitting Q. And hit B for dimension. Let's dimension the distance of the center point, or simply selecting this horizontal construction line. Let me place our dimension here. Key in 30. Okay. Dimension tool still active. Let's dimension this arc as well. Selecting this. Key in 10. Let's place those 2 circles. Hitting C for a circle, creating 2 circles here. Left click, dimension field active. Okay, so I'm going to key in 10 for this. Create another circle. Left click. Selecting our equal constraint. Selecting this circle and this circle. Okay, let me move this dimension over here and this dimension over here. Our sketch now fully defined. Let me select this green check mark, zoom out, hit Shift 7 for isometric view. Okay, so let's turn this into 3D, hitting Shift E. Okay, so prompted to select a face. Once more, we can also extrude a face and a sketch region. So I prefer creating a window selection to select all of this sketch region. So notice I have currently 3 faces of sketch 1 selected. Okay, so once more, let's change the path to be symmetric. And for the thickness of this, it's initially 5. Okay, I'm going to hit the green check mark. So in addition, notice our sketch, okay, the visibility of our sketch is now off. So whenever a sketch is being consumed by a feature, the sketch's visibility is automatically turned off. Okay, so let me head back, isometric view, and let's create the cylinders protruding on both sides of this part. Okay, so yes, in addition, we can reuse sketches as well. Okay, so notice we have initially created those 2 circles. Okay, so I can head over to our feature tree and turn its visibility on by left clicking on this eyeball. So notice we are now seeing that sketch. Okay, so no need to create a new sketch for that circle. Hitting Shift E for extrude. Next, notice as I hover over this face, and yes, you're right, if I left click on this, okay, I am currently selecting that face. Okay, and our intent or target is to select that circle. Okay, and this face is currently blocking our objective on selecting that. So to select nested items, it's simply right-clicking. So notice here we have this menu and simply selecting Select Other. So we're given another window. And as I hover over this option, Face of Extrude 1, it's currently highlighted with an orange color at the back. Notice that. Face of Sketch 1, that's our target circle. Face of Extrude 1, the face at the back. Of course, our target is that circle. So selecting that, let me head over to Top View. And I prefer the direction of this extrusion to the other side. So in addition, I can select these arrows to flip the direction. Okay? And notice our extrusion is coming all the way at the middle or center. Okay, so with that in mind, instead of keying in 15, okay, 15, we are extruding at this plane or line at the middle. So we need to consider adding 2.5 to that as well. And in Onshape, we can do mathematical operations in the dialog boxes. So I'm going to type in 2.5 plus 15. Okay, so I'm performing an MDAS operation, currently doing addition, hitting enter, and I want you to take note of the operation. We are, the Boolean operation, we are going to add a new material. Okay, so in the later stages, of our upcoming trainings, we will be dealing with these features, and we'll dive into more information. Okay, so notice the result of that, 17.5, hitting the green check mark. Let's repeat that. I'm going to hold the Shift E, the shortcut key for extrude. Okay, hovering over our target sketch region, right click on this, selecting select other, and selecting face of sketch 1. Left click on this. And to reiterate, once more, I'm going to type in 2.5 plus 10. Okay, and hitting the green check mark. Okay, so in addition, notice as I select this front plane, it's currently highlighted in orange. If you would like to deselect any specific item or feature, it's simply left clicking on the blank area of our graphics window. So I'm going to left click anywhere here to deselect. Okay, so that's for our young ones who are absolute beginners into the world of CAD. Okay, so let's clean things up. I'm going to head back to our sketch 1, and I prefer not seeing this sketch any longer. Selecting this eyeball, turning off that sketch visibility, and hitting P as well to turn off our planes. Yes, and congratulations, we have now created the target 3 parts for this challenge of creating a rotator assembly. Okay, so moving forward, the fun part. Let's now put all of these parts into one as a dynamic assembly. So once more, plate now created, the crosslink, the link. So the link being just an instance or a copy of our another part. And once more, let's get organized. I'm going to head over to assembly, right clicking on this, selecting rename. Let's rename this to rotator dash assembly. Hitting enter. Okay, so selecting our assembly tab. So notice here we have a different menu or window at the right. Okay, so we're going now we're going to add in all of these 3 parts into this rotator assembly tab. Okay, so to do that, it's simple. I'm going to head up and select insert. Okay, so with this Onshape document, we are given the 3 part studios that we currently have. Okay, and to bring in that part, it's simply twirling down. Okay, twirling down this arrows. For this instance, let's bring in part 1. I'm going to left click on this. Okay, and as I move out of this, head to our graphics window. The part is currently attached to my cursor. Okay, so if I left click on this, that is where Onshape places our part. Okay, so another best practice, once more, which I have mentioned a while ago, is having the origin at the center as much as possible. So we need this origin of our assembly coincident with the origin of our plate part. Okay, that one. Heading back to our assembly tab. And a great way to do that, to have them initially coincident, their origins coincident with one another, is I'm going to delete part 1 for now. Head back to insert once more. And this time, instead of left clicking part 1 and heading over to our graphics area, I'm going to simply left click on part 1. And notice this time, the origin of our plate together with our assembly, their origins are now their origins are now coincident with one another. Okay, so with that, I will still be in this window and immediately head up and select that green check mark. Okay, so that's a quick tip on how to position your incoming parts into the assembly workspace. So to show you, let me head over to top view. Okay, it's at the center, heading over to front view. It's at the center as well. Okay, so this is not yet. Recall that in part modeling, we use sketches to fully define our part. In assembly, let's think of it as the counterpart for constraints from sketches. In assembly, it's mates. Okay, so this one is also different, a game changer in comparison to our previous existing CAD, parametric CAD softwares out there as well. So this one is straightforward and has more intelligence. Okay, so instead of having selecting or adding assembly mates, notice here, our mates are currently named as fastened, straight to the point, revolute, okay, slider, okay, ball, so on and so forth. So once more, we'll be having a continuation, a guru series. If you want to be serious in learning Onshape. Okay, so I haven't defined or added constraints / or mates yet. So definitely this part is free to move. So it's not currently having it's currently free to move, having its degrees of freedom. Okay, so I'm free to move. Okay, so I'm going to hit undo to revert back. Okay. Next, another best practice. I'm going to head over now to our part 1. Okay, so we have identified earlier that the parent part of this assembly is our plate, right? So the crosslink and the link will be attached to our plate. Okay, that's the reason why we initially inserted the plate into our assembly. So with this in place, I'm going to head to part 1. Okay, and I'm going to right click on this and select fix. And by selecting fix, we are locking all of this part's degrees of freedom. Okay, so we have that 6 degrees of freedom. So those are all locked into place. Okay, so notice I cannot move this part any longer. So that's one of the best practice when initially doing an assembly. But of course, it may depend, okay, on what you are doing. But typically, this would be the best flow for that. Okay, so moving forward, this is now fully, let's say, constrained or fixed. Let's now add the linked. Okay, so heading back to rotator assembly tab, heading back to insert. Okay, so in addition, you may be familiar with the S key. Okay, so whenever we hit S key, this one is contextual. So this varies the commands listed varies whenever you hit S key. So in this instance, we are currently in the assembly mode. And as I hit S, all of the commands or tools here listed are the tools necessary to be in the assembly mode. So take note for that. This is an additional tip. So to prove that, let me head over to our part studio, to our part link. I'm going to hit S. So notice this one is different, okay? Once more, this is in context to what you are currently working at. So I'm currently in the part. So definitely in the part, initially we'll be creating a sketch. So all of the pertinent commands are listed whenever you hit S on your keyboard. Okay? Looks familiar, right? Okay? So I'm going to head back to rotator assembly. Instead of heading up, I'm going to hit S. And I'm going to select insert. Okay, so I prefer inserting the link for now. Selecting part 1. Okay, so I don't have the need for this to be coincident with our origin. So this is free to be placed somewhere around here. Left click. Okay, and to create another instance for that, it's simply heading back to our inserts, parts and assemblies window, selecting part once more, and left click here. Okay, so I'm going to hit the green check mark. And now, obviously, our intent is to have this cylinder be inserted to the hole of our plate. Okay? And the appropriate mate for that, as we hover over here, is obviously revolute. Okay? So it can also be a cylindrical mate, but this face of our link should be planar or parallel to this back face of our plate. So the appropriate mate for that in this instance is our revolute. Okay, so I'm going to hit or simply select revolute mate. Prompted to select mate connectors. Let me discuss or share to you what mate connector is. So once more, think of this as our version of constraints. When creating a part, we have constraints. When creating an assembly, we have mates. Okay? To our young ones who are absolute beginners. So once more, prompted to select a mate. I'm going to place my cursor, hover over here. So notice I'm currently hovering over the front face of our plate. And notice there's let me call him, her, Pac-Man. Okay? Notice that disc appearing at the center of the front face of our plate. And in addition, it has a triad. Okay? The X, Y, Z. Okay? The blue one, the Z, Y, the green X, red, the X. Okay? So that lines are pertaining to the positive values. Okay? So once more, notice this disc shape. This is called the mate connector. Now, as I move my cursor, it snaps to these points. Okay, to this point. So it snaps to this circle, white circle at this corner, to this midpoint. Okay, to this corner. So take note of that. Okay, so taking note of that. So I'm going to hover over this face. So notice this shape mate connector, hovering over this face. Also onto this link. Okay, so moving forward, we are prompted once more. We are prompted to define that mate connector on each, once more, on each of our part. Okay, so I'm going to hover over this face, left click on this. We have now defined the mate connector for our first part. Next, we're not yet done. I'm going to hover over, zoom in to this cylinder's face and select this mate connector. Left click. Okay, and notice those two mate connectors mated, okay, or touched or went or coincident with each other. So that's the concept of a mate connectors in Onshape. Okay. So in addition, we have this window. I can flip the axis. Definitely it goes the other way around. I can reorient. We can solve this for full assembly, and of course, simply selecting the green check mark. Okay, so let me cancel this out in this instance, and notice the effect of that revolute constraint. So I'm going to hover over this face, left click and hold, and I am now rotating this part, our link, into our plate. Okay, so that's the intelligence, the difference of mate connectors in comparison to traditional CAD systems. Okay, so let's move forward. I'm going to hit S for now and select our revolute mate. Prompted to select a mate connector, and this time, here's another tip, an important tip. Our target mate is this mate on this face. Okay, so notice I'm going to select this mate. Okay, next. Previously, we selected this cylinder's face. So for now, let's add some variation. I'm going to hover over this face. Okay. And in addition, in Onshape, we can hold shift to lock on to a specific face. Okay, so right now, I'm not holding my shift button on my keyboard as I hover over this top face. Okay, so this is currently now highlighted. Hovering over here, this is now highlighted. As I hold shift now, so notice I'm holding shift and I move my cursor over here. Okay, we are now locked on this face at the back of plate. So once more, holding shift to lock to a specific target face. Okay, so once more, holding shift just to make sure and selecting this mate connector. Okay, so notice the difference between the two. They are both correct. So the goal is to have that mate connectors, mated with each other. So selecting the green check mark to commit on that. Hitting escape. Okay, we have now placed our two links, and finally, let's bring in our cross link. So I'm going to hit S and select a revolute. But of course, I forgot to bring in our cross link. So once more, hitting S, selecting insert. Okay, twirling this down, selecting part 1 for a cross link. Okay, placing this part over here, hitting the green check mark. And yes, for this basic introduction to CAD with Onshape, we will be utilizing the revolute mate once more. But of course, we will be having a series of live stream trainings, progressing from basic all the way to advanced to help you out pass the certification. Yes, we do have a certification for Onshape. Okay, so heading back, hitting S, selecting Revolute Mate. So notice in this instance, we are in the Fasten Type Mate. Okay, so we have that the ability to change this by basically selecting this drop down. So notice the list of available mates. So for this, selecting Revolute once more. I'm going to hover over this face, hold shift just to make sure, locking to this face, selecting this mate connector, moving over here, selecting this mate connector, left click, selecting the green check mark. Okay, so I want you to see that effect. Okay. So, and finally, let's have this cylinder inserted over here. Hitting S, selecting Revolute Mate, hovering over this face or the cylinder. Okay, for that to happen, we need to zoom in, holding shift, selecting this mate connector, and selecting this mate connector. Hitting the green check mark, and cancel out. Revolute, and yes, congratulations, we have now created, okay, your first assembly in Onshape. Okay, so we hope this opened new doors for you, most especially to those who are currently using the traditional, for example, to those who are using CAD. So CAD, AutoCAD. So this is more straightforward, okay, in creating, if your intent is to create products, okay, that will go to market. This is a great way of being direct to the point of creating models, okay, so products, parts with Onshape. Okay, to our educators out there, of course, being with it's pandemic, right? So another advantage, shout out to our educators, is, as you can see here, the burden for the parents, of course, in having to have their children purchase a powerful laptop for CAD. What I'm using here is simply a web browser. Okay, so with the web browser, we can use Onshape. Simple as that. So not only that, I'm sure most of our students right now are doing online classes. This is also the power of Onshape being a cloud-based technology. So yes, this is available. You can use Onshape. You can access Onshape using your Apple tablet, your Android tablet. Same with your phone. Okay, so that's, we hope you have learned something new. And yes, we are open to support educators who may be inspired to adapt CAD and Onshape into the classroom. Okay, so yes, CAD is a powerful way to influence young ones to, we call it STEAM, not STEM. Art is very much important as well. So yes, with CAD, of course, they can know geometry, they will get to appreciate math. And Ms. Delcy mentioned a while ago, the feature script, that's coding. So we can inspire them to there as well. And by learning CAD, this will lead you this will inspire young ones to pursue different fields in STEAM. Okay, so once more, we are free to support everyone who might be interested in adopting Onshape in the classroom. Okay, so for those who would like to have an official certificate of course completion, this, yep, all you need to do is forward the link. That's how simple it is in Onshape. You don't have to forward the file right away to me. All you need to do is click the share button. Okay, so you can you're free to type in the email. So later we'll be sharing the email for you to forward your outputs. So once more, for those who are interested to have a certificate of course completion, we are requiring you guys to submit an output, and that output is, you may have finished creating the challenge right now. Okay, so simply to share your output, simply type in our email, which will be provided after this uh, training. So yeah, simple as that. Creating a 3D model in a CAD browser. So yep. So yep. In addition to those who may be wondering, can we export the files? Okay, so if you're planning to, if you're using different CAD systems as well, yes. So let me show you under. I'm currently in a Part Studio Part 1. Simply selecting export. Right, guys? I right click on export. So here, here's the option for exporting the format. I can export this to step. Okay, I can to our Rhino users. Okay, I can also export this to Rhino. Yeah, and OBJ STL for 3D printing for those who are doing 3D printing in the classroom. And SolidWorks. And that's SolidWorks. Just to add, the creators of SolidWorks created Onshape. Okay, so yep, that's why we are seeing SolidWorks here. So once more, the original founders of SolidWorks created Onshape. So yes, powerful tool if you have a quick idea. Yep, design in mind. Simply grab your phone, your tablet, your web browser. Simple as that. Create a powerful 3D model. Okay, so once more, thank you everyone. To those who attended this live stream training, and yes, more to come. Okay, and on our next live stream training, definitely we will be having more. We will be sharing raffle prizes. Okay, so once more, to share your outputs, it's simply hitting the share button, and initially that gives me access to your designs. Simple as that. And yes, this is a powerful method of bringing in collaboration. As you know, product design is also heavy on collaboration. Have your students collaborating on an awesome project. Okay. So moving forward, sharing to you guys, we are here to support you all the way. Sharing our initial schedule for Onshape Guru Series 2021, which will go on monthly. I think this will happen on the 3rd of Friday, monthly at 7 p.m. So as you can see, the topics here, this will help you out in taking up the challenge of Onshape. Yes, Onshape also has a certification exam. Okay, so we hope to see you guys on the upcoming Onshape trainings. Once more, for updates, please help us build the largest Onshape community in the world by joining Onshape users worldwide. We are also in Facebook, LinkedIn, and shout out to our friends in Digital Creatives for making this possible as well, and to our PSME, Philippine Society of Mechanical Engineers, Parañaque, and student units for making this possible. So once more, if you have questions, feel free to message us. It may be in LinkedIn and Facebook. And yes, thanks for watching, and we hope this helps. And as a so once more, thank you so much, and have a great afternoon, everyone. Hoping to see you soon.
It used to be that you would design under one roof and then manufacture under one roof. What we've seen is a lot more specialization. Expertise has become fragmented, and as a result, each of these people need to coordinate and work together in the design process. They can be across the state, across the country, across the globe. And so people need tools to be able to interact and communicate. We took the opportunity to look at how the CAD world had evolved, how product design had evolved, and how the computing infrastructure had evolved. And we decided to hit the reset button on product design software.
Onshape is building a new generation of CAD, one that's designed for teams to use. Everyone on the team can use it anywhere, on any device, anytime.
We're capitalizing on the platform, the cloud, mobility, and redesigning essentially what CAD is to help people design products faster, easier, and more affordable.
20 years ago, when we built SolidWorks, we built CAD on the modern computing platform, the Windows PC. It runs only on that computer. When it comes time to work as a team, users have to use all these schemes to copy files, check in, check out. It's kind of a hassle and it costs them time. Today, CAD still runs on that Windows PC, but people are used to using their phone, their tablet. People are used to working on multiple computers and going into a web browser.
Teams are built up and torn down quicker. There's a lot more collaboration. Tends to be a lot more contractors, a lot more consultants.
And so the rest of the computing world has changed a lot, but CAD hasn't. And it's time for CAD to evolve.
You know, users, they're like all of us. They're tired of trying to figure out what's the login password for the data vault, because I don't use it all the time. And when I get the assembly, all the links are broken.
License fees, installations, license managers.
Do I have the right version of the part or the right version of the assembly?
I visit CAD users. Years ago, I talked to them about modeling cool shapes and cool products. But in recent years, when I visit users, they're talking about all the hassles of CAD. And it's time to get rid of all that.
Users today expect that we should just be able to access information and share and work with other people real time, much like the way that Google does for working on a Word document. We've done that for the CAD world.
We get to collaborate on the same geometry, which was never done before. We have found ways to break down our modeling paradigms, our assemblies, our models, our features, so that multiple engineers can collaborate on the same feature, which was never done in CAD before.
The cloud is really a transformational platform.
We put the CAD system and the CAD data in one place in the cloud, and one master copy of the CAD data that everyone can access simultaneously from anywhere through any device. So there's never any copying of a CAD system, and there's never any copying of CAD data.
When we're working on something simultaneously, you see visual cues to understand what part of the model you're working on, what part of the model I'm working on.
Even people who see Onshape once will say to me, "Hey John, can I get a copy of Onshape?" And I say, there is no copy of Onshape. I don't have to send you a copy. You can log in from any computer. You log in through any web browser and you have access to the whole system. Even if you have an iPad or a phone, you can use Onshape.
It can be used by the single user working at home, the small design professionals, small teams, through to some of the largest manufacturers in the world.
CAD users, product designers, engineers, they don't sit at their desk all day. They're in meetings, they're moving around, they're at the coffee shop, they're having lunch, they're home thinking about it on the weekends. Wherever they are, whenever inspiration strikes, they should have access to CAD, and with Onshape they do.
Browser technologies, mobile technologies, and cloud technologies are converging and giving the capabilities to build complex system like ours.
What we are doing here is very forward-thinking and innovative, and we have the team that can achieve this.
We've got people who are the most experienced, talented, smartest software engineers and CAD engineers that I've met in my career.
And so it's serious CAD, it's serious design software.
You'll get products done faster by teams, and you'll get them done better because they have more time to spend on engineering. And finally, I think engineers and designers will have more fun. Onshape's just more fun to design with.